So the point of this task is to use the dynamic capabilities of the program to, first of all, visualize what it looks like for a regular polygon to change as number size changes. So there's 4 sides, 5, 6, 7, and you can do this a lot more easily using the software. Okay, so the first part of the problem is to write an expression using n, the number of sides. We want to base it on n that represents the sum of the angle measures. Notice I have the angle measure here, but I don't have the sum, but that's easy to do because I can just calculate the number of sides times the angle measure, and now I have the sum. And I could even, for the sake of making it look nice, change the word to sum. And now as I do that, as I change the number of sides, you can see that the sum changes. Okay, so that measurement, the measurement and calculate buttons are really nice on here. Okay, so I want to figure out how the sum changes based on the number of sides. One thing that I can do is I can tabulate. So I can go to this, tabulate, and I can click on number of sides. As I change the number of sides, it fills in the table for me. So looking at the table, the student might be able to make a reference here and notice that from 180 to 360, you're changing by 180 degrees, to 540 to 720, and they might be able to notice that this is a linear equation with a slope of 180, or they might not. So another thing that you can do is you can click on those and you can plot as a point. And I'm going to also trace this point so I can see where it goes. And as I change the number of sides, this trace looks linear. Okay, so I can test that out and see if it is linear. So what I can do is, you can take any two of these and you can determine the equation of a line, and that would bring out a lot of discussion of how to get the equation of a line. Or you could use the capability of the software to do that for you. So one way to do that is to plot points. And I'm just going to pick points from this table to plot. I'm going to pick 4 and 360, and 5 and 540. We know 2 points determine a line, so that's enough. And I can make a line and measure the equation. And now we have an equation that corresponds to this table and this graph. That is the sum of angle measures based on the number of sides, which in the equation is x. Okay, so that gives you a variety of representations fairly quickly and easily using the software. The next part of the problem is to find the measure of each angle. So obviously we've already discovered this relationship between the angle and the sum because that's how we made the sum to begin with. We multiplied the angle times the number of sides. So students might conjecture that all you have to do to find the angle measure is divide by number of sides. So we could just write our new function, which would be what we just found, 180x minus 360, and then divide by number of sides. So that's a really funny looking equation, and we want to know if it's correct. Another thing that we can do using the software is we can graph that equation. We can graph the correct equation. That's better. But it looks funny, so I don't know if that helps us or not. So, well, let's see what else we did. We can plot the same point, or we can plot points like we did before, but now notice our point is on here because we use the angle measure. So if I change my number of sides, see how my point goes right along my equation, and you can use that to demonstrate that this is the correct equation because that's where all of the points lie, is right along that equation. So that this gives us the sum of the angle measures, relying on the number of sides, and the measure of each angle, depending on the number of sides. So that's the end for this problem.